Hello everyone, welcome to my channel. And this is my tutorial about the artificial intelligence and neural network. Today I'm going to explain about the simple neural network, which is called the convolutional neural network, and I'm gonna give some codes with Pythons about this architecture. So I'm going to explain the simple architecture and neural network, which is called the neurons or perceptron, which is given with the real neuron of human. So if I'm going to explain that what is this cells doing is that from dendrite we get the information from outside and collect it, and then we process it with cell bodies. Then at the final, in the axon terminal, we make a activation or decision based on the cells. So already we have some W weights inside the cells. That is information that already we given. So according to the X, we are trying to make a decision and make decision. So here, as you can see, perceptron also is like these cells has X data, and the inside the cell body is W, which is weight, and sums, activations, and output. So this is called perceptron algorithm, which is used for supervised learning and binary classification, and usually represented by a series of vectors belongs to a specific class. In short, a perceptron is a single layer neural network. They consist of four main parts, including inputs value, and weights, bias, and some of the weight and bias multiplication and activation function. So the process is begin by taking all the inputs values and multiplying them with their weights. Then all of the multiplied value are added together to create the weight sums. The weighted sums here is then applied to the activation function, and the activation function plays the integral roles of ensuring the output is mapped between 0 and 1 or -1, 1. So right now I'm going to do some coding from the spider, and I want to say that I assume that you have some information about neural network. That's why I'm going a little bit speedy, and I'm going to, and also I'm assume that you have information some about the coding, especially in Python programming. So I'm going to right now explain the code and how is the perceptron is written in Python. So we have to first of all import NumPy. NumPy is a library which is worked with digits. So first I want to define a class with the name of the neuron. Then first, as I told you, is we have many parts in the perceptron, which is first is weight, activation, bias. So I have to use initial function to initialize it. So I'm using self, weights, activation, and bias. So first we have to define it. Self weights is equal to weight then self activation is equal to activation and self bias is equal to bias. So after defining this initial method, I'm going to define the output. So as I told you, is the weight and input values is multiplied as a matrix. So I'm defining here output self, and we have x values that is new here, and then we will use np dot methods to self weights and x. Then we will return it as a self activation, which is consist of db is the result plus self bias. Then I'm going to define the sigmoid. Sigmoid function is a kind of the activation function, and I'm going to show you the sigmoid function also. So it's return 1 plus np exponential minus x. So I'm going to show you how is the exponential sigmoid function. The sigmoid function is mostly from 0 till 1, or sometimes it can be defined as a -1 to 1. So first I'm gonna show you. I want to plot it for you. Then I'm going to define x from -10 to 10 with 100 numbers, and yeah, y is our output sigmoid, which is x. So I'm going to plot it. And I'm going to pause it for one second. Then I'm going to, till now I can play it for you. We have invalid sentences. I guess it should be this. So we have no line spaces. Line, not line. Yeah, we have here, yeah, line space. So I'm going to play it. So as you can see here, the sigmoid function is the function that is mostly is between 1 and 0, and it's because we want binary classification, so the classified function, the classified import is 1 or 0. So I'm going to show this with defining x value. X is equal 1.2 2.5, for example, 6.7 and 8. Then I'm going to define the weights. So let's have a weight with 3, 2, 1 and 4. Then I'm going to call the class which is defined here, class of neuron, with W, and activation function is sigmoid. Then I'm going to see the results. Is then neuron output with X, and I'm going to print result to show for you. So here I'm going to run selection. It's not defined, so I'm going to name activation is not defined. We have error here, so I'm going to do this self activation, undefined name activation, activate. Sorry, here we have problem activation, so I'm going to find it. Neuron Network activation. So we have, I guess, problem here with activation, activation. So let's right now I try to solve the problem, and you can see our output is here put of the sigmoid function in perceptron. So function you see here is 1. We can change it with different value here. Yeah, you can see here by changing the values is the output also change. So here is the simple neural networks that I hope you enjoyed it. If you have any question, you can